NASA just uncovered a discovery that could change everything. New research suggests that our galaxy may be teeming with microbial life. While this doesn't confirm the existence of living organisms, it does reveal a potential biosignature, an important clue in the search for extraterrestrial life. Thanks to advanced space telescopes, multiple Earth-like planets have been detected much closer than we ever imagined. These so-called second Earths may hold the key to answering the age-old question, are we alone? For years, the idea of another Earth seemed like science fiction, but not anymore. NASA's cutting-edge instruments, including the James Webb Space Telescope, JWST, have opened up a new era of discovery. No longer limited to spotting distant worlds, scientists can now analyze their atmospheres, surfaces, and potential for habitability. The concept of the Goldilocks zone, a region where a planet is not too hot, not too cold, but just right for liquid water, has become central to this search. And now, we're finding planets in this zone in surprising numbers, close enough to study in detail. Among the most exciting discoveries is the TRAPPIST-1 system, just 40 light-years away. Revealed in 2017, this ultra-cool dwarf star hosts 7 Earth-sized planets, 3 of which, TRAPPIST-1 E, F, and G, reside in the habitable zone. These planets orbit so close to their star that all 7 could fit within Mercury's orbit in our solar system. Despite this tight formation, the cooler temperature of their host star means they're not overheated. Their likely tidal locking, one side always facing the star, could result in extreme but fascinating climates. Observations from the Hubble Space Telescope suggest at least 3 have rocky surfaces and lack thick hydrogen-dominated atmospheres, promising signs for habitability. Further out, 124 light-years away, lies K218b in the constellation Leo. Unlike TRAPPIST-1's rocky worlds, K218b is a Haitian planet, larger than Earth and possibly covered by a global ocean beneath a hydrogen-rich atmosphere. What set off a scientific frenzy were recent JWST findings indicating the presence of dimethyl sulfide, a compound on Earth produced almost exclusively by marine plankton. Alongside methane and carbon dioxide, these gases could suggest biological or geothermal activity. While the results are still under review and could have non-biological explanations, the implications are profound. Another breakthrough came from NASA's TESS mission, with the discovery of the TOI 700 system, about 100 light-years away. This calm red dwarf star hosts at least 4 planets. 2 of them, TOI 700d and TOI 700e, are in the habitable zone and are nearly Earth-sized. The idea of 2 potentially habitable planets orbiting the same star is astonishing and offers unique opportunities for comparative study. Recent discoveries have shaken our assumptions about how far we must look. LHS 475b, just 41 light-years away, is Earth-sized and orbits a red dwarf star. Even closer is Proxima Centauri b at 4.2 light-years, our closest known exoplanet, situated within the habitable zone of its host star. Though Barnard's star B, 6 light-years away, is likely frozen, it remains valuable for understanding planetary evolution. These planets, often orbiting M-dwarfs, cooler and more common than our Sun, increase our chances of finding life-supporting conditions close to home. The JWST is not just a telescope, it's a revolution in space science. Operating in infrared, it sees through cosmic dust and deciphers the chemical fingerprints of distant worlds. By studying how light filters through a planet's atmosphere during transits, JWST can identify elements like water vapor, carbon dioxide, methane, and potentially even biosignatures like dimethyl sulfide. It's building a catalog of exoplanetary atmospheres, turning theoretical discussions of habitability into data-driven investigations. Its findings are helping redefine what makes a planet truly habitable. Ideas once confined to movies like Interstellar or Avatar are now part of active scientific inquiry. The notion of colonizing other planets is no longer far-fetched. With missions like Artemis and Mars projects, and the ambitions of private space companies like SpaceX and Blue Origin, humanity is preparing for life beyond Earth. But with this comes ethical responsibility. Who decides how we interact with new worlds? How do we avoid contaminating alien ecosystems? And how do we prepare humans, physically and psychologically, for the challenges of deep space? From analyzing atmospheres to planning interstellar probes like Breakthrough Starshot, humanity is taking its first steps into a larger cosmic journey. With dozens of potentially habitable planets already identified within 100 light-years, the search for life is no longer a dream, it's a mission. The more we uncover about these second Earths, the more we realize how unique and fragile our own planet is. As we look outward, we're also gaining new appreciation for the home we already have. The universe is vast and full of secrets, and now for the first time, we're on the verge of uncovering them. Stay curious. The search for a second Earth has only just begun.